Hey all, so in this video I'll be going over the 2024 Specialist Maths Exam 2, the NHT, and I'll be going over the MCQs in this video. I'll be going over the extended response in the other video, so make sure you are tuned for that. Okay, so without further ado, let's get started with the MCQs for today. So consider the following proof. Prove that this and assume that, so they're using the opposite. Okay, then that, and then that, and hence that. Okay, so this proof can be best described as a proof of contradiction, because we are assuming the opposite and then we are proving that way, so it is a proof of contradiction. Okay, so question 2, we already have the pseudocode. So consider the following algorithm to estimate the arc length of a certain curve. Define f of x, return x squared. Okay, so it's very important that you understand the code. So all what this is saying is f of x is equals to x squared, and then these are our variables that we are going to be using in this following question, or this following pseudocode, I should say. Okay, so initially the sum is set 0, a is set as 1, b is set as 2, h is set as 0.5, left is equals to a and right is equals to a plus h. Okay, so while right is less than or equals to b, do this. So basically, while this is true, we have to keep executing what is inside the while loop over here. So this is basically saying a plus h has to be less than or equals to b, which is 2. Okay, and so arc is equals to this formula over here. Sum is equals to sum plus arc. Left is equals to this, that. Okay, so these three are our increment statement basically. So every time this formula is executed, then these three increment statements are applied to do the next iteration. Okay, so what do you have to find? So corrected to decimal places, the above algorithm will print the value. Okay, that is not a problem, so I'm going to erase all of this. Okay, so first let us take this step by step. So first, let's write down that we know that f of x is equals to x squared, and initial sum is equals to 0. And for our first iteration, we have the following values. So 1. So we have to first write the right. So right is equals to, what is right? So a plus h. So initially our a is 1 and h is 0.5. So 1 plus 0.5 is 1.5. Then we have the left, which is equals to just a, so just 1, and h is equals to 0.5. So then our arc is equals to f of 1.5 take away f of 1 whole squared plus 0.5 squared. Okay, so let us find the arc first in our calculator. So define f of x equals to x squared, and then we'll have the square root, just square root of f of 1.5 take over f of 1, and that thing whole is squared, plus 0.5 whole squared. Do that, that is 1.34629, so 1.34629. Okay, so that is our first iteration. Now let's have a look. So while right is less than or equals to b, so currently our right is 1.5. Is 1.5 less than or equals to 2? Yes, then we have to do the next iteration. Okay, so let's write down the values for the next iteration. So 2, and now right, what would right be? So now if you look over here, right is the previous right plus h. So 1.5 is what we had previously. Now we do plus h to that. So we'll have 1.5 plus 0.5, so that is 2. And then what about our left? So left is the same thing. It is the left that we had previously, so this one, plus h, which is 0.5. So 1 plus 0.5 is 1.5. And our h is just going to be constant because there is no increment or decrement statement for h. Okay? So now let's input all of this into the arc formula again. So we'll have f of 2 take away f of 1.5 whole squared plus 0.5 squared. Okay, and now let us calculate that as well. So 1.5, and this one will become 2. So 1.82. Okay, so 1.82003. Okay, now let's look at the third iteration. So number 3, we will have, what is our right? So right is now equals to previous right, so this plus h, which is 2.5. Now notice one thing. This condition is not met anymore because 2.5 is not less than 2. So we cannot have the third iteration. So this is all we have to calculate in terms of, in terms of the iterations. These are the only iterations we need. Now we have to find the sum. So sum is the previous sum plus the arc. So our sum will basically become 0 because that is what we have initially, plus the sum that we obtain after the arc that we obtain after the after the first iteration, so 1.34629, and then plus this over here, so 1.82003. So let us do this on our calculator. So that plus that, we get 3.16, so 3.16632. So what is our option? So I think it's going to be option E for this. Okay, hopefully this made sense. We have to go very slowly with these questions, but yeah. Okay, so question number 3, the graph of this has 2 intercepts when? Okay, so I guess we have to do this question on CAS as well. So let's define our f of x equals to 1 on 1 minus x squared, and then take away a. Let's find the x-intercepts first. So f of x equals to 0. Okay, so this is our first intercept, and this has to be greater than or equals to 0, which makes complete sense, because if this is not the case, then this would become undefined, or it will go into complex. Okay, and yeah, and this is our second intercept, and of course this has to be greater than or equals to 0. So basically this will have 2 intercepts as long as this is going to be greater than 0. Okay, so if I do solve, that has to be greater than 0. It can't be greater than or equal to 0. The reason being that if it's equal to 0, then this would become negative square root of 0, and this would become positive square root of 0. So we'll only have 1 intercept. We want 2. So it has to be greater than 0. Okay? Now why is it greater than 0? Because as you can see, the magnitudes of the x-intercepts are the same. However, the sign is different. So as long as this term is greater than 0, we will get negative for one term and positive for the other. So we'll have 2 x-intercepts. So that's why we can say that this has to be greater than 0. Okay, comma A, and yeah, this is going to be our answer. Okay, so I think the answer is just going to be E for this one as well. Okay, hopefully this made sense. So the solutions of this can be found by solving. Okay, I guess this is asking us to simplify and make the whole expression in terms of tangent. Okay, so what I'm gonna do is I guess I can start by separating the terms here. So it will be 1 on cosine squared plus 5 sine x cosine of x on cosine squared x minus 7 equals to 0. So this and this would cancel out, so this would not be squared anymore. This would just be cosine of x. So we can write this as secant squared x, right? Because secant is 1 on cos, plus 5 sine on cosine of x. So we can say it's 5 tan of x, right? Because sine on cosine is tangent. Minus 7 equals to 0. Now we can express this in terms of tangent as well by using the property that 1 plus tan squared x is equals to secant squared x, right? So we will have 1 plus tan squared x plus 5 tan x minus 7 equals to 0. So I'm just going to say that let a equals to tangent of x. So we'll have a squared plus 5a, and then 1 minus 7 is minus 6 equals to 0. Okay, so if I were to factorize this, because they want it in the factorized form, so we will have a plus 6 and then a minus 1. And now let's substitute the tangent back in. So tangent of x plus 6 and tangent of x take away 1. So this will be our answer. Let's see if it matches anything. So it matches option D. So answer is going to be D for this. Okay, hopefully this made sense. Okay, so for z belongs to complex number, a belongs to all real numbers, the discriminant of the quadratic equation, this is 36. The possible solutions for z to this equation are, okay, so we are given some information regarding the discriminant. Okay, so in that case, since we are given the quadratic equation here and the discriminant, we can also find the value of a, and then we can substitute the value of a to solve this, to solve for the whole equation. Okay, so let us do this on our calculator. Okay, so we have solve. What is the formula for discriminant? It is b squared minus 4ac. So we will have minus, or maybe I should do this, so minus a times I squared, so minus that, minus b squared minus 4 times a, which is just a times by c, so minus 5. Okay, and that is equals to 36 from what we have. So let's find the value of a. So our a is gonna be 2 or 18. And now if I were to write the whole equation down, so define f of z is equals to a times z squared, take away a times I times z, take away 5. Okay, and let's substitute the value of a as well. So let's start by a equals to 2. Okay, so now we solve for this. So solve that is equals to 0. Oh, C solve, not solve, because it's complex. So C solve. There you go. And now let's substitute a equals to 18, the other solution that we found. Okay, so C solve that equals to 0, comma z. Okay, so these are our solutions that we get. Okay, so let us come back to our iPad now. So z is equals to 3 on 2 plus or minus, oh wait, no, it's the other way around. So it is plus or minus 3 on 2 plus I on 2. Okay, that is our first set of solution. And then the second set is equals to plus or minus 1 on 6 plus I on 2. So now let's see which options actually match. Okay, so I guess we have to take out the common value. So let us take out half from here. So that gives us 1 on 2 plus or minus 3 plus I. And then for this one, we can take out 1 on 6. So 1 on 6, we take that out. So we'll get plus or minus 1 plus 3i. So that matches with option A. So our answer is going to be A for this. Okay. So the equation, okay, defines array in a complex plane, identifying the complex numbers x plus yi with the points x, y. This ray lies on the line with the equation y equals to mx plus c. The values of m and c are respectively. Okay, so let us do this question on calculator. So let us define our z to be x plus yi. Okay, now if we do solve and angle, and we just have to type what the ray give us. So z plus 2 minus I, and that has to be equals to pi on 3. And if I do y, see, there you go. So this is the equation of the ray. Okay, So let us determine the m and c. So our m is going to be this value over here, which is just root 3. And our c is going to be 2 root 3 plus 1. So let us see which one matches. So from calculator, we found that m is equals to root 3 and c is equals to 2 root 3 plus 1, right? So our option is going to be D. Okay, so that's how we do this question. So let's move to the next page. So let y equals f of x be the solution to a differential equation dy over dx plus 1 dy over dx equals to 1 plus 2y with the initial condition f of 0 equals to 1. What is the approximation for f of 1 using Euler's method, Euler's method? I don't know how to pronounce it, so I'm just going to go with Euler's method, starting at x equals to 0 with a step size of 0.5. Okay, this is also a calculator based question, so let us do this Euler, and then we type down the dy dx of 1 plus 2 times y, not equals to 1 plus, there you go, comma x comma y, comma, why are we putting dots? So x comma y, and then that. So we'll have 0 to 1, and then we have 1, and then our step size, which is 0.5. So it is going to be 5.5 using the Euler's or Euler's approximation, whatever you call. So answer is going to be E for this. Well, answer is going to be E. Okay. So using the substitution, u equals to x squared, u squared equals to x plus 1, the definite integral can be expressed as. Okay, so if u squared equals to x plus 1, then u is equals to square root of x plus 1, right? And the second thing is that x is equals to u squared minus 1. So the other thing that also changes is the terminal, so do not forget that. So our x is equals to, or actually we have to use the other equation, so u squared, u equals to square root of x plus 1. So our x over here is 3, so 3 plus 1, which is going to be 2. And then the other terminal, which is going to be 8 plus 1, which is going to be 3. And then let's find the du dx as well. So du dx is equals to 1 on 2 root x plus 1. So how do I do this? Like, there is a secret, not a secret, there is a way that you can, just know what the derivative is for these kind of surds. So let me just quickly show it to you, the proof. So let's say that this is our f of x, right? Y equals to this. And if you're finding dy dx, we can also write this as f of x to the power of a half. So if I'm finding the dy dx, we'll do 1 on 2 times f of x to the power of minus 1 on half times derivative of f of x, right? So then we will get dy dx is equals to f dash of x over 2 root f of x. Okay, so that's how we can use this I guess shortcut, if you want to say it's a shortcut. Okay, and that's how, just by using this formula, I know that if we differentiate this, we'll straight up get what we have here. Okay, so hopefully this made sense. Alright, let me erase all of this. Okay, so then we have dx is equals to 2 root x plus 1 du. Okay, so now we'll have integral from 1 on x plus 1, and then 2x plus 1 dx. Du, I mean. Well, this is, not in the correct notation because our integral is in form of u. So you better not write that down in the extended response section like this, okay? But this is just a step I'm writing down to show you how it simplifies. So this and this would cancel out, leaving us with 2 on x. And what is our x? So our x is u squared minus 1 du. So in the actual exam, like in the extended response section, if you have to, transform the integral, make sure you do not include this step. You just directly write this down, okay? So this is our integral, and from 2 to 3, basically. Well, it doesn't match any of the options. So what I'm going to do is I'm going to try expand this out in our calculator. So let's do this on calculator. So expand 2 on x squared minus 1 there. So if we expand it out, we will get this over here. So let's copy that down real quick. So 2 to 3, 1 on x minus 1, take away 1 on x plus 1. Well, not x, it's going to be u in this case. So u. Okay, and that. Let's see if that matches anything. Okay, so it matches option B. Okay, so the length of the curve is given by this and that, so where t is between pi on 6 and pi on 3 is given by this. Okay, so for this question, the best way I suggest you guys do is to just, do the trial and error method. So find the arc length of this and then check with all the other integrals to see which one works the best, because there's no point, transforming all of this. You could make a mistake and you can lose the mark. Plus, it may be very time consuming as well. So the best way out is just by using the trial and error method. We'll go from option E to option A because usually the answers are from C, D, or E. There's barely any time where I've seen options being A and B, like very little chances. So let's try that on our calculator. So let's find the derivative of the x term. So what I'm gonna do is I'm going to say that define f of t, okay, equals to, I'm going to say that x term, so 3 times 1 minus tangent of x, or maybe tangent of t, whole squared. Okay, let me put an extra bracket just so I do not confuse this. Okay, so that is our f of t. Let us define g of t. Well, define g of t equals to, now we'll define the y term, so 4 times sec of t squared. Okay, and now let us differentiate these two. So define df of t is equals to menu for 1 x and f of, well, t, not x here, so let me fix that. Okay, and we'll do the same for gt. So define dg of t is equals to menu for 1 t g of t. Okay, now we can just apply the arc length formula for parametric, and so that is just going to be the square root, well, integral, and then our bounds are pi on 6, so pi on 6, and then pi on 3, and then we have the square root of dx dt squared, which is just df, which is just this function squared basically. So we'll have df of t whole squared plus dg of t whole squared, and that, so 40 on 3. So this is the actual arc length that we have, and now we will substitute all of the other integrals. We are going to try all of the other integrals and see what each of them evaluates to. So whichever one evaluates to this will be our answer for this. Okay, so let us try option E. So menu for 3 pi on 6 to pi on 3 square root of 2 times square root of 10 of t. Okay, this is getting a bit confusing. Maybe I'll just put square roots in. I don't want to mess up with the brackets. Okay, so the square root of 2 times square root of tangent of t times sec of t whole squared dt. Okay, can it not evaluate this? Okay, oh, Control C, there. So not this. Okay, well, what's this evaluating to? 13.3. Okay, cool. So let's try option D now. So that is going to be menu for 3, so pi on 6 to pi on 3, and then 28 times tangent of t whole squared, okay, times by sec of t to the power of 4 dt. 133. Not this either. Let's try option C. So option C is basically this, but this is squared, and tangent isn't squared, and this is going to be 2 rather than 28. And that is option C. Okay, just making sure I did it correctly. Okay, not this either. So option B now. So we'll take this down, and nothing changes other than this becoming 100. 477. No. Let's try option A. So tangent. So again, nothing changes other than this is multiplied by 10. Okay. There you go. So our option A is going to be our answer. This is one of those rare occasions where the answer was option A, but most of the time is within C, D, or E. Okay. So yeah. Let's go to the next question. So consider the surface area of the revolution formed by rotating the curve y equals to 1 on x for x between 1 and a about the x-axis. The area of the surface is given by, well, we can just apply the formula, right? So let me bring the formula sheet up. So what is our formula for this? Let me see. Formula for that. Okay, so we are rotating about the x-axis, so we will have 2 pi y and then times it by square root of dy dx squared, 1 plus dy dx squared. Okay, so let us go back. Where were we? Yeah, just here. So our formula was from 1 to a, 2 pi times by y, so 1 on x, times by square root of 1 plus dy dx squared, so that is going to be 1 on x to the power of 4 dx. So, well, 2 pi is written outside because it's a constant, so let's do that. So it's from 1 to a, 2 pi. Does anything matches our answer? Well, not in this form. So maybe what I can do is, I guess we can try writing this down in our calculator and see if it gives us an alternative format. Maybe that could work. So let's do square root of 1 plus 1 on x to the power of 4. Okay, it did. So let us copy that down. So this is same as 1 to a, 1 on x, times by square root of x to the power of 4 plus 1 times by x squared. So all of this would get multiplied and we will have x cubed basically. Okay, and dx. So let's see if that matches anything. Yes, it does. It matches option C. Okay, so question 11, if n is equals to this, where n is all natural numbers, then for n is greater than or equals to 2, in is equal to. Right, okay. I guess looking at the integral here, you can kind of say that this is an integration by parts question. Because, well, the calculator is not going to be able to solve it because it's to the power of n. If it was an exact number like n equals to 2 or something, then it will be able to give us an answer. But since it's to the power of n, it's not going to be working. So I guess we have to do this manually using our hand. So we know that in is equals to what we have. So 1e x squared log base e x to the power of n dx. So I'm just going to use integration by parts. So let u equals to, well, we can't let u equals to this because, well, we don't know how to integrate this. So we have to let u equals to log base e x all to the power of n, and let dv is equals to x squared, because we do know how to integrate this, right? So we have our du dx is equals to, let us just differentiate on CAS, no point doing it by hand. So we'll have menu for 1x, then we have ln all to the power of n. Okay, so we get n on x log base e x to the power of n minus 1. And our v is equals to, we just integrate this, so we will get x cubed on 3. Okay, now we know the formula for integration by parts is integral of u dv is equals to uv take away v du, right? So in this case, since we already have the bonds, so we can just say that u times v is going to be x cubed on 3 times what is over u. So u is just that, so log base e of x all to the power of n, and this is a definite integral, so our bounds will be the same, so 1 to e, and then take away the integral of v du. So that will be from 1 to e. V is x cubed on 3, and then du is going to be n on x log base e x n minus 1 dx. So this and this would cancel, well, this and the x term would cancel out, giving us x squared. Okay, so let us simplify this again. So x cubed on 3 take away log base e of x to the power of n, 1 on e, and then this will be 1 to e, and x squared on 3 log base e of x minus 1 dx. Okay, so then we can take out n on 3 because those are the constant. Okay, so x cubed on 3 log base e x to the power of n 1 to e minus n on 3 e x squared on 3 log base e x n minus 1. Well, not 3 anymore, just x squared. Okay, so x squared. Very well, it looks like we're just going to have, because if I put n minus 1, this will become n minus 1, which had the same integral. So we will basically have x cubed on 3 log base e of x, and then 1 to e, take away n on 3 times I n minus 1. So now we just have to evaluate this integral over here, and we should be good. So let's do that. So we will just type the thing down. So x cubed on 3 times by log of x, that to the power of n. Okay, and then we will have x equals to e, so that, and x equals to 0, no, 1, so that take away that. Okay, well, if I put n equals to 2, because that's the least n can take with the domain, so e to the power of 3 on 3, so e to the power of 3 on 3 take away n on 3 I n minus 1. So option D looks like the answer for this. Okay, so question number 12. Okay, so we are given a direction field, and that it represents a differential equation. Okay, and we'll figure out which one it is. So okay, there's two things I notice really quickly as I look at it. The first key point I notice by looking at the differential, this field, is basically that at x equals to 2 for the whole part, our gradient is going to be 0, so there is no slope. Okay, and the other thing I notice is that for y equals to 2, we have gradient as undefined throughout. So using these 2 points, we can easily find out what the dy dx is for this. So let's see. So option A, so x squared. So at x equals 2, so let's substitute y equals to 2. If dy dx is undefined, then that's going to be our answer. So if I substitute y equals to 2 in here, will it give me undefined? No, so it can't be option A. If I substitute in y equals to 2 here. Yes, that does indeed give me undefined, so I'm going to keep that for now. Option C, again, this is not going to give me undefined, so 0, no. And then option D, again, can't give me undefined at y equals to 2. Option E, yes, it can give, so the now it's between B and D. So let's substitute in x equals to 2 and see if the gradient is going to be 0. So if I substitute x equals to 2 here, we can see that it's going to be 8 minus 4 on, yeah, so that doesn't give us 0, the 0 gradient. So it can't be option B either. But option E, if we substitute in x equals to 2, it does give us 0. So option E is going to be our answer for this, okay? So a racing car is traveling on a straight horizontal track at the velocity of 80 meters per second when the brakes are applied at t equals to 0. Okay, so from t equals to 0 to the moment the car stops, the acceleration of the car is given by at equals to this. During this time period, the distance the car travels, correct, to the nearest meter is. Well, we know that to go from acceleration to position time graph, we have to integrate this twice. Okay, so we have d2x on dt squared equals to minus 6t squared plus t is what we are given at the moment. So this is the acceleration, and now we are also given that at t equals to 0, it is traveling at a velocity of 80 meters per second. So using that, we can find the velocity equation as well. So let us integrate this. So d2x on dt squared, okay, dt, okay. So if I were to integrate this, let's do this on our calculator. So menu for 3 minus and 6 times t squared and plus t dt, okay. So we will get minus 2t cubed minus t squared on 2 plus c, okay. Now we also given that at t equals to 0, our velocity is equals to 80. So what we just found is v of t, right? So by putting that in, we can see that our c variable, our constant, is just going to be 80, right? So our velocity equation is just going to be from negative 2t cubed take away t squared on 2 plus 80. Okay, now we have to find the time, because if you don't know the time the car comes to a stop, we won't be able to find the position, right? So how do I find the time? Well, if the car is stopping, we know that the velocity of this has to be 0, right? So basically we have to find v of t equals to 0, basically, right? So let us do that on our calculator. So if I do plus 80 to include the constant, so solve, that is equals to 0 for t. We will get 3 equals to 3.34. So let me write that down. So t equals to 3.34. Now, one thing that we also know is that area under a velocity, let's say that this is our velocity time graph. The area under velocity time graph shows us the displacement, right? Or you can also say distance, because if it's speed, it's going to be distance. If it's velocity, it's going to be displacement, okay? So all we have to now do is to find the area under the graph from t equals to 0 to 3 equals to 3.34, essentially. How do I do that? Well, we just have to do a definite integral from 0 to 3.34 vt dt. And this will give us the distance the car travels, essentially. Okay, so let's do this on calculator. So menu 430. If I do, actually, let me first do that. If I do end, and I'll delete this. So now we have the whole thing. So menu 43 from 0 all the way to here, and then now we have to put the velocity equation in. So this, and put that in, dt, and enter. So this is going to give us 198.766. So the nearest meter is going to be 199. Okay, hopefully this made sense to you. Alright, so let's move to the next question. So an equilateral triangle is spanned by the vectors a, b, and c as shown below. Okay, the scalar products A dot B is equivalent to. Well, first I'm going to start by plotting these vectors on the Cartesian plane just to get the hang of the angles, because all we are going to be using is the dot product formula. So cosine of theta is equals to A dot product B over magnitude of A times the magnitude of B. That's the formula that we will be using. So to find A dot B, we will have that is equals to magnitudes of A, magnitude of B, and then cosine of theta. Okay, so first I need to find the theta between. First I need to get the angles right, because sometimes it's a bit tricky. I'll show you what I mean. So currently it just looks like it's all 60, 60, and 60, right? But if I were to plot this on Cartesian, you'll see the difference. So this is my vector A. Okay, then my vector C is just a straight horizontal line like so, and our vector B is going like this. Okay, and then this is 60, and then this is 60. So from vector A, C, B, so from vector A to B, the whole thing is going to be 120 and not 60 like it, we can see here. Okay, so make sure you're always careful about that. Alright, so if you want to find the dot product of A and B, we have to take the angle between A and B here. Okay, so what I'm gonna do is now substitute it in. So AB is equals to, we are not given any information about magnitudes, or are we? Yes, we are, right? Because this is an equilateral triangle. So magnitude of A is equals to magnitude of B, right? And all our answers are in terms of A. So we can assume that magnitudes of B is the same as magnitude of A. So we can write this as that squared cosine of theta, which is 120. Now what is cosine of 120? It's going to be negative root 3 on 2. So if I were to draw a unit circle real quickly, okay, so 120 is going to be somewhere here. And in quadrant 2, the cosine is negative. So that's why our answer is going to be root 3 on 2 negative, and then magnitude of A squared. So it looks like option E is going to be our answer. Okay. Alright, so question number 15. A normal vector to the plane that contains points these, okay, is. Well, so just for the sake of this question, what I'm going to do, I'm going to call this A, this as B, and this as C. Okay, now if I want to find a normal vector to all of this, it's just going to be our n is equals to BA cross CA. Or alternatively, you can also write CB cross AB. Doesn't really matter, okay? So let us define all of these vectors on our calculator, find AB or BA, whatever, and then CA, and then do the cross product, okay? So A is equals to 2 minus 1 minus 1. Okay, B is equals to 3, 1, 1. And C is equals to negative 1, negative 1, 2. Okay, so now B to A, vector B to A. So we are doing final minus initial. So what is our final destination? It's going to be A, because we are going from B to A. So it's going to be A minus B. And then C to A. So final destination is A. So A minus C. And then we do cross product. So cross P of that and that. Okay, so we will get 6i minus 9j plus 6k. Okay. Wow. Actually, well, we can take out, 3. 3 is our scalar multiple of our vector 2i minus 3j plus 2k. Okay, we can take 3 as our, because 3 is just a scalar multiple of this vector over here. This vector over here. Okay, so 2i minus 3j plus 2k. It is going to be option D for this. Okay. Alright, so if we just multiply this vector, oh, okay, low battery, okay. If we just multiply this vector by 3, we will get to this vector. So we can take 3 out as common factor for this. Okay, hopefully this made sense. Now if you do, CB cross AB, that also works. Doesn't really matter, okay? You can do it in using any vector, okay? So question number 16 now. So the position vector RT of a particle at time t is given by this, and the value of t when the particle's velocity is perpendicular to its acceleration is, well, if that's the case, we are finding r dot t, and then that double dot has to be equals to 0, because that's when two vectors are perpendicular, when their dot product is equals to 0. So this is all we are finding, and we have to find the time t. So let's start by defining the position vector. So I'm going to say s is equals to e to the power of minus 4 times t, and then e to the power of t. E. Okay, let me check if I've defined it correctly. Yes, I have. So that is all good. And now we have to differentiate this. Menu for 1 ts. So this is our velocity vector, and now let us find the acceleration vector. So menu for 1 dt. We differentiate velocity, we'll get acceleration. Now we'll do dot product of this vector and this vector, so velocity and acceleration, and that has to be equals to 0, comma t. So t is equals to 0.415. Can we get an exact answer? Yes, we can. So that is equals to t is equals to 3 on 5 log base e of 2. So that is just option D. Okay, so the angle at which the line with equation this intersects at the plane with equation this is, well, we can just use the formula for this. So we'll have sine theta is equals to the dot product between the direction vector of the line and the normal vector of this plane. So we will have root 2 comma 1 comma 1, and then we'll have root 2 minus 1 1. So this is the vector I got from this line over here, and this is the directional vector of this line over here, and then divided by the magnitude. So the magnitude of both of this, so square root of 2 1 1, forgot the bracket, times by magnitudes of 2 negative 1 and 1. Okay, and then we can just simply find this theta. Okay, so let us do this on our calculator, I guess. So we have dot product of square root of 2, actually has to be, so square root of 2, so square root of 2 comma 1 comma 1, and then we have another vector which is the same as this. Can't copy and paste. Okay, well, so we have square root of 2 comma minus 1 comma 1. Okay, so this is our dot product, and now we just will find the norm, multiply them. So we have that times by the norm of the second vector, that. So we have sine theta is equals to 1 on 2. I mean, it's 2 on 4, but simplifies to 1 on 2, right? And we know that theta is equals to 1 on 2. It's like sine inverse of 1 on 2 is basically going to be pi on 6. So our answer is going to be A. Okay, so you can use this formula if you want to find the angle between a line and a plane. Okay, so it's just sine theta equals to the dot product of the directional vector and then the normal vector divided by magnitude of directional vector. Okay, let me write that a bit more clearly to make sure I'm a bit quick. So sine theta is equals to the directional vector, which is the vector here, the direction vector of the line, dot product the normal vector divided by magnitude of this and magnitude of that. Okay, so this is what we use. Okay, hopefully this made sense. So the shortest distance between two parallel lines with the equations this and this is, very well, again we have a formula for this luckily. So the distance is equals to the magnitude of this. So I can call this d, so d 2 minus d1, and then divided by the a squared plus b squared plus c squared. So where this is basically, so our this formula, so let's say we have ax plus by plus cz equals to d1, ax plus by plus cz equals to d2. Well, because the plane is parallel, so these variables will be the same. Okay, so we will get, using this formula we can do this. So we have 6 minus, well, what I'm gonna do, I'm going to write this as as this basically. So I'm going to make the coefficients of x, y, and z the same by dividing it by -2. So we will get 2x plus 2y minus z is equals to minus, well, 12. Okay, so our distance is equals to 6 minus 12, and then it's going to be 2 squared plus 2 squared plus 1 squared. So that will be minus, well, not minus 6, 6 divided by, it will be 2 squared plus 2 squared, so that is 8 plus 1 is 9. So square root of 9 is going to be 3. So 2. Okay? So it's going to be option B for this. Okay? Alright. So yeah, just keep this formula in mind if you want to do any, Okay, just a disclaimer that this formula only is for the parallel lines. Okay? The formula will change if the lines are skewed. So make sure you keep that in mind. So if you have to find the shortest distance between two parallel lines, perfect, you can use this. But if you have to find the distance between two skewed planes, not lines, I mean planes, okay, two parallel planes, you can use this formula. But for, if the planes are not parallel, then please make sure that you do not use this formula, because this may not be applicable to that. Okay. But anyway, so since we are finding the distance between two parallel planes, this made it easy. Okay, so yeah, this is going to be it for this question. So answer is going to be B. Okay, so question number 19. When grown under the same conditions, two varieties of tomato plants have the yields, the quantity of the tomato produced, that are independent and approximately normally distributed. Okay, variety A has a mean of this and standard deviation of this. Variety B has a standard deviation, as a mean of this and standard deviation of this. The probability that a randomly selected tomato plant of variety B will have a higher yield than a randomly selected plant of variety A is closest to. So we want B to be higher than A, basically. So what I'm going to do is let B take away A is equals to D. And what we are then finding is probability that D is greater than 0. Okay, so let's find the mean of D. So E of D is just E of B take away E of A, just like here. Okay, so we will have 5 minus 6, so that is -1 kilogram. And then we have to find the standard deviation of D. So standard deviation of D is just standard deviation of B squared plus standard deviation of A squared. Okay, so that is just going to be 1.5 squared plus 1.2 squared. Okay, so let us do the rest on the calculator. Once we have the standard deviation, all we have to do is to use normal distribution to find probability that D is equals to 0 for the standard deviation of D and mean of D. Okay, so let's find the standard deviation. The square root of 1.5 squared plus 1.2 squared. Oh, can't type it. 1.2 squared. Okay, so that is 1.920. So 1.920. Okay, So now we have all the required information. So now let's just apply the normal distribution. So menu 5, 5, 2. So our lower bound is going to be 0, upper bound is infinity. Mean is going to be -1, and standard deviation is 1.920. Okay, I'm going to substitute the whole value in just to be very accurate. So 0.301 is what we get. So 0.301. So the answer is going to be C for this. Okay. A publisher prints a large number of notebooks and textbooks. The thickness of the notebooks is known to have a variance of this. So I'm going to say that our N represents the notebook. So that is equals to 0.04. And the thickness of the textbook is known to have variance of this. So variance of T, the textbooks, is going to be 0.16. The variance of the total thickness of a random sample of M textbook and N textbook is this. So variance of M notebooks, so M times N plus NT is going to be 4.36. And the variance of the total thickness of a random sample of N notebooks, so variance of N notebooks plus M textbooks, so M textbooks is equals to 2.44. And find the values of M and N. Okay, well, so this can be written as M squared variance of N plus N squared variance of T, right? That is equals to 4.36. And then this can be written as N squared variance of N plus M squared variance of T equals to 2.44. Okay? So in that case, we know the variance of N, we know the variance of T, and we just have to find two variables. We are given two equations. We know what to do. Well, we can just simply solve this on calculator. Just solve, and then we will have that. So we have M squared times, what is the variance of N? So 0.04, okay, plus N squared times the variance of T, which is 0.16. That has to equals to 4.36. Now N squared times by 0.04 plus M squared times by variance of T, which is 0.1616. That has to equals to 2.44 comma M comma N. Okay, oh yeah, one more thing, M and N has to be positive. M is greater than 0 and N is greater than 0. Well, the reason being that M and N represents the number of textbooks and notebooks. So we can't have, M is less than 0. There can't be negative number of notebooks and textbooks. So M is equals to 3 and N equals to 5. So we're M equals to 3 and N equal to 5. So it looks like our answer is going to be E for this. And okay, that's it. So end of the multiple choice question. Thank you guys for watching. Hopefully you learned something from this. And I'll see you in the next video. Bye-bye.